If you are new to this channel, make sure you subscribe, like and share. Today, I'm going to show us the techniques of differentiations. If you are new, please watch the previous videos on how to differentiate so that you will get this one better. Now, there are three techniques of differentiations. The first one is our product rule. Product rule. What's product rule? Product rule is talking about y equals to uv. Y equals to uv means that when you are using product rule, the two functions given to you must stand beside each other. The two functions given to you must stand beside each other. And what's the formula for product rule? V du dx plus u dv dx. What do I mean by two functions must stand beside each other? Like if they give you something like this, x plus 1, 3 plus x. So can you see the functions standing like this? So this one will now represent our u, this one will represent our v. So that is when to use product rule because the two functions are standing beside each other. So what we use is product rule. Now, and this is the formula v du dx plus u dv dx. Now the second technique of differentiation is quotient rule. Quotient rule. When I say quotient rule, that means it to be y equals to u all over v. Y equals to u all over v. So this one, when are we going to use this one? When you are having a question in form of divisions. And the formula is v du dx minus u dv dx all over v squared. This is the time to use quotient rule. And this is the formula v du dx minus u dv dx all over v squared. And that means you are having functions standing in form of divisions. That's when to use quotient rule. Like when you are having something like this, x plus 1 all over x minus 1. So what you use when you are having something like this is quotient rule because it stands in form of divisions. Lastly, we have what called chain rule. We have chain rule. Chain rule. When are we going to use chain rule? When we are having a function of a function. Function of a function. Like when you are having something like this. You are having function of a function. This is what we call example of a function of a function. That means before you can get answer, you have to substitute something here. You have to solve whatever that is there. When you solve whatever that is there, this one alone is a function. The function. So after getting this, you now square it. Squaring it again, that's another function. That's why we call it function of a function. That means if you are using chain rule, that means you must give something like function of a function. And what is the formula for that? Divide the x for that one is because this one, when you are trying to differentiate this one, you can represent it with u. The second function represents it with another letter. So to give us the y, the u, multiply by the u, the x. Actually, it will give us the y dx back because when it comes to the u, it gives you the y dx back because we differentiate it 2 times. Whenever they give us function of the function, we are going to use chain rule because we are differentiating it 2 times. Now let's do some questions using this. We are going to treat the question like this. We're going to treat it taking them one by one. Because in some cases, the three roots, a question's under differentiation can make sure can allow you to use the three roots to answer this one. But we are going to start from simple by using it one after the other. Before we now start attempting some questions that we have to use the three roots or 2 roots in solving one. Let's start it one by one. Now, we would like to solve all these ones and many more under the chain rule. But let's start with all these simple ones first. Now here include many so that we can, I want us to have the wider experience on how to use the chain rule. Now let's start picking it one after the other. A, we say y equals to 3x squared minus 2 raised to the power 3. Now, without telling anybody, we should have known that these are functions of a function. So we are using chain. Now, how do we solve something like this? The first thing to do is that I told you we have to solve this one first by representing with a letter. We represent this one with u. So u equals to 3a squared minus 2. Now we see we have u and x. That means we find du dx. Du dx. That's why I told you, if you have not watched my previous videos on how to differentiate, please go back and watch it so that you know how to differentiate. Now when we are to differentiate this 3x squared, that means we are using this power to multiply this. That is 6x. And differentiation of 2 is 0. So differentiation of this is 6x. Now, after we have represented this one as u, we now rewrite it and say y equals to, this one has turned to u. That means u raised to power 3. So now differentiate y and u, that is dy du. He said dy du. Now what is dy du? If you are to differentiate this, you are taking this power to multiply this. That is 3u, and you remove 1. That is 3u raised to power 2. After you've done that, you've gotten your du dx and you have gotten dy du. You can now find dy dx. Don't forget the formula. Dy dx equals to dy du multiplied by du dx. That is how to retain. So what's our dy du? Our dy du is 3u squared multiplied by, what's our du dx? Our du dx is 6x. So the answer is 6 times 3, that is 18x u squared. But you won't leave it like this. You have to substitute the value of u. That means 18x, open the bracket. What's our u? Our u is 3x squared minus 2. 3x squared minus 2 raised to power 2. So that is answer for number 1. For the number 2, same way, represent everything you see under the square root by letter u. That means u equals to 1 minus 2s cubed dx. Du dx. What's the differentiation of 1? 0. So that one has gone. What's the differentiation of minus 2s cubed? You use this 3 to multiply minus 2x. That is minus 6x. And you remove 1 from this 3. That will be minus 6x raised to power 2. That's the differentiation of this. You now rewrite it and say y equals to, don't forget this one has turned to u, square root of u. And how do we write this one? We write it as y equals to u raised to power 1 over 2. That's how to, the square root to use this. You will now differentiate dy du. Dy du. So that will be, we are using this one to multiply this. That's 1 all over 2 multiplied by u. And you are removing 1 from 1 over 2. 1 all over 2 minus 1 over 1. That means dy du equals to 1 all over 2u. You find your LCM. Your LCM is 2. 2 into 1. 1 times 1, 1. Minus 2 in 1. 2 times 1, 2. That is dy du equals to 1 all over 2u. 1 minus 2 minus 1. So you can actually write it as dy du equals to, you can just bring this one down and take away the negative. That's 1 all over 2 u raised to power 1 all over 2. So do not forget, we now find dy dx. Find dy dx. So our dy dx will be, since we have gotten our dy du, we have gotten our du dx. These are the two things we need. Dy du multiplied by du dx. And what's our dy du? This is minus 6s squared. So you multiply them together. So that will give me minus 6x squared all over 2u raised to power 1 over 2. As you can see, this one can cancel this. That's minus 3x squared all over, what is u? I told you we substitute for u. 1 minus 2s cubed. Doesn't 1 minus 2s cubed is to power 1 over 2. Or you can just turn it as a square root on it. So that is answer for number 2. Let's look at number 3. Now let's take a look at this one. I'm going to use the same thing, chain. So we represent this one by u. What to see is a function of a function. U equals to 6 minus n squared. Now you might ask me that why am I using the chain rule? Why can't I use what's it called? Why can't I use quotient rule? Are they not standing in front of divisions? Yes, you can use quotient rule. But for the fact that you see the function of a function here, you are advised to go with this. So that means the u dx equals to 6 is 0. You differentiate this one to give us minus 2x. Now that means the y equals to 5 all over u. Don't forget this one has turned to u raised to power 3. That means the y du equals to, if I want to differentiate this, like I told you when I was explaining differentiations, bring this one up. That'll be 5 u raised to power minus 3. That's why I told you that you may not need to use any quotient rule, but it will resort to this. So that means the y du, we just multiply this one by this. That is minus 15 u. Remove one from, say minus 1 here, that's minus 3 minus 1, minus 4. Minus 4. And divide it. Now let us do dy dx. Dy dx equals to dy du multiplied by du dx. What is my dy du? Minus 15 u raised to power minus 4 multiplied by u dx is minus 2x. So bring this one down to take away this negative. That'll be minus 15 all over u raised to power 4 multiplied by minus 2x. So your answer is minus and minus plus. 15 times 2x, that is 13x. All over, what is u? We substitute for u. 6 minus x raised to power 2, close bracket, all raised to power 4. So that's the answer for that. Now let's take a look at this d. All over square root of